Good. Hi everyone, can you hear me fine? Okay, so I'm Andrea Barisani, I'm from Italy, he's Daniele Bianco, and we had this little project about playing with cars and traffic information, and we just want to share our fun research with you, and I think you're the perfect audience for this. So we gave this presentation at Black Hat and one other conference as well, but I mean, I'm very honored to be here and explaining all of this to you. So as you can see, we have some gear here that we brought in the States, and as you can imagine, that wasn't a very easy thing to do. So because when you travel with this kind of thing in the baggage, you get always these kind of things. So TSA baggage of inspection notice, and this is our FM transmitter, which kind of looks like a bomb. And so when the TSA officers, got it at the inspection, there's a small switch over there, so he got it, and he said, okay, let's try this. Boom! So apparently TSA officers are allowed to make those kind of jokes. Well, if you make those jokes, you get arrested. So I found that to be very, very, very amusing. But anyway, we got the gear. They broke it, but we fixed this. So hopefully we're going to demo the thing for you. We also have a very, a slightly big antenna over there, which we call the Deserializer. So if you ask silly questions at the QA, we just point it at you with full power. So injecting traffic information signals. So what's this about? So this is about one hacker, or well, I hope so, getting a new car with a new satellite navigation system and traffic information channel going on, and before even driving the car thinking, oh wow, that could be interesting, I could play with that, let's see what's going on. So in-car satellite navigation system in Europe and in other places, I'm going to go in detail about that, so they can get dynamic traffic information, and the system being used for that is called RDS-TMC, okay? So we'll show how we can hijack these kind of messages and do pretty much whatever we want. So why do we want to do it? Because hardware hacking is fun, because it's very 80s, because we're using FM, RDS, so 80s, which means cool. So, and also the problem is that drivers usually implicitly trust this kind of information on the car. So my dad has a similar navigation system, he sees an alert over there, oh, I'm so going to do that. So this could be a slight problem. And more important, chicks will melt when you show this, and we're going to prove that to you, which is basically the whole point. I mean, we don't hack for money, we hack for chicks. So radio data system. So RDS is used for transmitting data over FM. Whenever you have a station and you see the name of the station on your radio, that's RDS doing some work for you, okay? So it's used pretty much everywhere. 100% of radios nowadays, they display RDS system. It's describing a standard. So what happens here? Here we have, can you see the pointer somewhere? Okay, so we have the mono section of the FM spectrum. We have a pilot tone at 19 kilohertz. Then we got the stereo information. And then at the 57K subcurve, we have the RDS signal, which, what are you doing? Which is used for, I'm like talking to people here.
I'm sorry.
Yeah. So at 57K, we get zeros and one over there, okay? So not audio, we get something that is going to be demodulated, and we can get data, and it's all cool. We have the digital word. So RDS-TMC was first introduced in Germany in 1997, where else? Germany. So it was implemented out in Europe in the following year. So Italy got it in 2004, and just so you know, it's a very old technology, like RDS is very 80s, but Australia is getting RDS-TMC in 2007, right? And most satellite navigation systems are using this kind of traffic message channel thing only in the last couple of years. So it's very, very relevant. So what happens, you got your traffic messages like the cops, the stations on the highway, they detect a queue or whatever, and they're sent to FM broadcasters, and then they are going to send the information over their RDS stream, and then that's going to be picked up by your car. So it's implemented in most, so if you buy a car and you get a satellite navigation system within the car, so it's built in, then most of the times you get TMC. Or if you buy high-end portable satellite navigation system, you get TMC. If you buy low-end navigation system, you can buy an external antenna and you pay for it, you install an additional software, and you can get RDS-TMC capabilities. TMC is available in both free and commercial services, and I'm going to go in detail about that. And it can also be transmitted over digital radio. And our research applies as well. So that's a RDS-TMC terminal. So we can see we have the traffic event list. So we have a very cute icon. Then we got the event. So there's the patchy fog, the first two, and slow traffic. We got the name of the road. And then, so those are Italian roads, so the name is weird. I'm sorry for that. I apologize. And then we got how far the event is. And if you click on that, or whatever, you press a button, then you get a map, and then you can see where the event is. And this is like interactive, you can see the event list. So if an event is affecting your route, then you're going to get a pop-up in some circumstances. Okay, so you can either browse the existing messages, or it's going to pop up for you. So the issue, there's no form of authentication of the data. There's some form of encryption supported, but it's not really encryption, and I'm going to explain about that. And anyway, even if it was properly done, is absolutely irrelevant to our goals. So what we wanted to do, we wanted to send fake TMC messages against our victim by using off-the-shelf components. So we didn't want to spend like $10,000 for doing this, more or less like 100. And you'll be the judge of our results. This is the victim. So it's very cool when you're doing IT talks, like you got the victim slide and it's like a box or a server. This is a fucking car. That was my secondary motivation for doing the talk. The first one was chicks, as I mentioned already. So this is the victim. So first thing we need to do is like sniff RDS information for actually understanding the protocol and see what's going on. So we need to get a raw FM signal, right? We don't want the audio component. I want the whole spectrum so that I can play with it and I can demodulate my RDS subcarrier. So the easiest way for doing that, you buy a PCI audio video tuner, the cards that you put in a PC for, you know, watching television or radio. And what happens, so this is the board, and that's a normal PC, by the way, without a case, so but this way is more hockey and cool. And so what happens, you can hijack one of the pins on the board, and you will get the raw FM signal, and then you can do whatever you want with it. So if you go to that link, there's a list of cards. You can find tuners that are known to have this MPX pin available. So we use the one using the FM1216 module from Philips, which is available on like 80% of boards that have FM tuning capabilities. So once we have the carrier, we build a circuit using a TDA733OB, which is one of the most common chips used in cars for demodulating RDS. Okay, so that chip does the job for us. And then what we want to do is we want to be able to read the data, right? And so we use a programmable integrated controller for converting that information into serial, so we can hook that up to a PC, and then we can see stuff. And then we can decode whatever is going on there, and we wrote our own software as RDS-TM, which is available open source for decoding RDS, and specifically RDS-TMC. So there's one other project going on, RDS-TM, you will see there, which tries to do the same thing, but it's outdated, it's not been updated in a long time, and we just wanted to focus on TMC, and they don't. So that's why we did our own thing. Plus, it's cool. So this is the board, which is this thing, and there, that's the pin we hijack TMC. So maybe we can turn these lights off so that they can see the slides better. I don't know. I don't know if you can see this properly, but anyway. So this is triggered. So you might. Are you busy or shall I talk?
No, yeah, I'm busy.
Okay, he's busy. Okay, cool. So sniffing RDS. So what happens? We have the VHF tuner. Okay, we get the MPX signal. We pass it over a circuit. This is the circuit. Okay, very crude thing. So here we got a TDA, which is this thing here, and then we got logic for converting this to serial. So it comes in MPX, it gets out serial and zeros and one, which is cool. So we take the digital signal and we pass it over the serial input of the PC, and then we have our RDS decoder software. Okay. So main components: one TDA 733OB, which is like, you know, $10, a PIC microcontroller, which is like $7, and, you know, this board doesn't cost more than, yes, $16 or whatever. Assembly. So you can see our very advanced lab. So we even got a bed near the assembly for like burning the circuit. So because we wanted to attend and nurse, you know, our assembly. This is circuit. So if you want to build it on your own, you can, you know, get the slides on our website. You can do it. It's very easy. I mean, we're not technical guys, right? We type on the keyboard all day. So if we were able to do this, anyone can do. trust me on that. So peak programming. So we program peak for converting the RDS signal. We use a custom peak programmer, which is a variation of a very well-known programmer. So it's all, standard stuff. And what we get out are zeros and one if the quality is good. So the demodulator chip knows when the signal is bad or when the signal is good because it performs some sort of checksum thing. So if the data is bad, with an asterisk and a plus, okay? So what you can do, you can either ignore sequences with bad data or you can replace them with zeros and one, and if you feel lucky, maybe, it's going to work. So we programmed the peak with our own assembler code, which is available, open source, you can download it, have fun with it. So you can do everything that we did here. So this is the output. So that's an oscilloscope. That's the RDS signal sniffed over the air. So there's a wave, and that represents zeros and one. And that's one example of what we can get. So zeros and one, that's a very crappy signal. So we can see some zeros and ones, and the other one are crappy data. Can we get a demo? Or?
No.
Okay, well, fix it.
Yeah. Thank you.
He's my slave. Not in a sexual way. Should be careful. So this is the RDS protocol. It's very simple. It's designed to be space efficient because there's not much room for sending data. It's not like we have wireless in here. It's like radio. So we have a group of 104 bits. We have 4 blocks. Every block is 26 bits, 16 bits of data, and 10 bits of check word. The check word is like a checksum. It's being used for, it's computed against the data, and we can see if the packet was good or not. Of course, this is not like, normal checksum, which are very reliable. Since we have, like 26 bits, it's not too much. It's binary. It's zeros and ones. Even if the check word is right, it doesn't necessarily mean that the data is good. You can get good checksum that matches the data, but still it's not good. So not a very safe method. And that's why sometimes on your radio, when you see the program name, it's like garbled. It's like radio question mark whatever. Even if the checksum computation is working, you can get bad data. The first block of every group structure has a PI code, which is a program identification code. Every radio station has one code. It's 16 bits. And block 2, we have a group code, which is used for advertising what kind of packet this will be. So with RDS, we can send the station name, we can send alternate frequencies, we can send you the time, we can send you the information about current channel being broadcasting a traffic program. So that's advertised by the group code. So depending on what group code we get, which is a 4 bits code, those remaining 5 bits over there, they change. Then we got B0, 1 bit is for version. TP is this traffic program. It's 1 if a traffic program is going on. It's 0 if there's no traffic program going on. And that's being used because you can tell your radio, stop the CD or the cassette when there's a traffic information program, which, drives crazy most people that, buy radio for the first time. At least I remember 15 years ago, my dad was going crazy. Oh, I want to listen to cassette and then use information. But so that's the fucker that does that. And PTY tells you what kind of music you're listening to. It could be jazz, country, blues, whatever. So on some radios you can tell, I only want to listen to jazz music, and then you can do that. I've never seen that being used at all. But anyway, it's there. So TMC uses RDS in this fashion. So we have the PI code, of course, that's, should be there. Group code, B0, TP, PTY, and then we got 3 bits, TF and DP. Then we got a direction bit, a PN bit, the extent, so the extent of the event and location. So let's go in details in all of this. So this is a TMC message, how it's going to be, used. So TF and D are used for multi-group messages. So in TMC, we can either get our information in one group structure, or we can get our information in more group structures. So if you want to send more information, they can do that. We only concern with single group messages here because it's easier. DP is duration and persistence. I got an accident, we estimate it's going to last for 1 hour. Or you got a queue, we estimate it's going to last for 3 hours. We got emergency telephones not working on the highway, that's an all-day event. So that's being used for telling you how long the message should be stored on your satellite navigation system. Diversion advice. If it's 0, the satellite navigation system does not recommend you a diversion. Okay, so suppose there's a weather message like rain. The satellite navigation system is not going to say, oh my God, there's rain, please use a different road. No, that's not going to happen. But if there's like, a major accident on the highway, then the satellite navigation is going to pop up a window saying, there's an accident, you really want to go somewhere else. And then you can decide if to detour, so calculate a new route which eludes that accident, or to stick on your current path. PN is used for direction, so we want to be space efficient, right? So we have a location code on a highway, and then with that bit we says if the event is affecting one direction or the other one. And also we got the extent, so the event extension. We can get a queue which is like 3 miles long, 4 mile long, or 1 mile long. Okay, so that's what it's used for. And then the event code, which actually says what's going on. So there's a table on every satellite navigation system with predefined codes. So the satellite navigation system gets the code, it converts it to a human readable message, and then you get your event. Same thing for the location code. So there's not enough space for sending GPS coordinates. So what happens, every satellite navigation system and every country has its own location database table. And in that table, you're going to map location codes with GPS coordinates and road names as well. Okay? So one important thing to understand is that we can only send and receive messages about predefined location codes. We cannot send the message wherever we want, like here, not only on roads. In most cities, you can also send messages in the city, in ports, depend. But anyway, it's a predefined location table. There's a standard for the location table. Some countries gives you a public table, so you can download it on the internet, or sometimes you need to hack your satellite navigation system for getting it. So you got your DVD for your navigation system, you do strings on it, oh, oops, I can see a location code, but you're not supposed to do that. So we built our own tool, SRDS-T, Simple RDS Decoder. So it's performs nearly full RDS-TMC decoding. It's the only tool we are aware of that does that, except of course satellite navigation systems. So you can get text and HTML output. It's very easy to use, and you can pass a location table to the tool. So it's going to convert your location code to actually GPS coordinates and stuff. So you get a row. Does it work? No. Bitch. So you get a row signal, which is 0s and 1. So the first thing you need to do is lock in on DPI code, because that's where your RDS stream starts. The PI code is public most of the times. You can download very big Excel sheets on the internet with all the FM stations, and you can get the PI code. But don't worry, if you don't know about the PI code, it's simple, the most recurring string in the stream, because it appears in the first packet of every RDS group. So you just use the -P option, and you can find the most recurring string, which in this case is 5218, and that's also a hint. The first digit of DPI code, it depends on the country. And so we know that 5 is Italy, so that's our candidate. And then you can use it for decoding the row string, okay? And then you can see the packets going on. So this is like Ethereal or Wireshark for RDS messaging. So this is a standard RDS messages. It's a 0A group, is a tuning information, okay? And this is also the one that gives you the name of the station. And in every packet, we can get only 2 letters. So we got RT here. And also the tool gives you the collected letters. So the name of this station is RTL102.5, and here we got RT, okay? So this is very useful, because when you're messing with such a short protocol and you got 0s and 1s, even if all 0s and 1s are gobbled up, you're going to get something that makes sense, because it's always going to decode, right? So one way for checking it, that you're actually getting the real thing and you're not messing up the circuit completely, is checking the name of the station. If it makes sense, then it means your tuning is good, everything is working, okay? Or of course you can also check the check word, but as I said, it's not very reliable. So this is our tool decodes that just for, you know, seeing things going on and actually confirming that you're getting a good dump. 8A group. So 8A groups are used for the TMC message itself. So this is a single group message, is about slow traffic, so that's code 115 is slow traffic, and then we got the location, which is 3084, which is a very, very big road in Rome, and you get this all the times. We are in Italy, remember? So you're flooded by slow traffic and everywhere, an accident. And there you get a Google Maps link, so you can click on it and you can see if actually your message makes sense. We also got a version that plot everything on Google Maps, and I'm going to show you that. And this is a free aid group, so very important thing. This is used for advertising the TMC capability on that channel. Because it's not that your satellite navigation system is going to watch on all frequencies, it needs something that advertises the fact that TMC is being used, and that's using the free aid group, which is a general packet. It's not specific to TMC, but this packet has an application ID of 52550, which is the number reserved for TMC, and then you can get a custom data part, so it says which location table number I'm looking for, and if this is an international scope, a national scope, or a regional scope. So it's an advertisement of TMC capabilities. So this is plotting all events on Google Maps, which is also useful for C if the messages make sense. So if you see a big chunks on events in Rome and Milan, you're set. I mean, it makes perfect sense. Now, video clip time. So we want to show you why injecting RDS-TMC is good and why you can get late because of that. So we thought it was very, very important to stress that point. So we got a video for you. In this video, we mentioned the first conference, the video was shown, but you're not going to see that because I will be redubbing that part with my magic ninja skills. So just pretend you're not hearing that. So it's a very cheesy movie. Do we want to see the cheesy movie? Yeah. Good, DEFCON. Prepare to be rocked.
Okay, darling. Let's go home.
Okay, sweetheart.
I love my new toy.
I know. You love it more than me.
There is a queue. We have to detour.
But there's no one on the street.
No. I trust in my nuts.
But I can see the house.
No.
Oh, fuck you.
Shut up. Where the fuck are we?
Look how good is a navigator now, huh?
Who the hell are you? Ha! I'm the evil hacker, and with my portable device, I injected RDS-TMC messages onto your navigator. So now you are in my power. You are useless. Yes. My navigator. Yes.
Who are you?
I'm the evil hacker, and I have all this knowledge because I follow
DEFCON,
the best conference in the world.
Yes, you're the real man.
Can you feel my power?
Yes.
Love me.
got the chick. Case in point, it works. But, warning, your experience may differ. Cannot vouch for that. So that's why we wanted to do that. So, does it work now?
Yeah.
Oh, really? Okay, just a second. You fixed. Good. So, injecting RDS-TMC messages. So we use a commercially available RDS encoder, $40. You can build your own. We just didn't have time for it. It's very easy to do. And you can talk to this thing using I2C bus, which is a very, very common bus. So this thing comes with a software that you can use for, crafting very standard messages about radio tuning. We just build our own code so that we can fully send whatever we want, okay? So we set all parameters, PI, PTY, and so on. Then we got the free RDS blocks that we can program as we want. And the check word is automatically computed by the chipset, okay? So we don't need to bother about that. And there, you got a link, you can download the code, and then we can do whatever we want with it. So this is how we do it. So the code is very crude. So crude is code rushed and ugly because of unexpected deadline. And you modify the source code, and there you can set whatever you want to send. So you set the PI buff, the name of the station, and then you got those two custom fields. So you set hexadecimal values there. So we can see the first one is 85, which translated into binary. So we got 100000101, and the first 4 bits are the group, which then is 8. So it's an 8A group. Or we can see there we got the event, which is 01101100, which goes to 108, and then that's queuing traffic. Okay, so we can see binary. That's like being Neo and the Matrix. Cool. Forget assembler. Doing binary is way cooler. And then you can set the location table, okay? So you know the location table, you can set your destination of the message. If you don't know about that, you just sniff some messages, you correlate that with whatever you're seeing on your navigation system, and then you can build your own table if you cannot dump it from the navigation system. So this is how it works. We got our I2C application talking with parallel port to the RDS encoder, okay? And then, very important thing, we got an FM transmitter, which is the thing that looked like a bomb, okay? So main components, one encoder, one transmitter, one peak again. We need a digital PLL tuning, and then an antenna. So for building the FM transmitter, which is one of the most critical part here, it needs to be very, very stable, because we're not sending audio information. We're sending a digital signal. So it needs to be very stable, and so that's why we need a digital PLL tuning. And also we want to be able to use whatever frequency we want. We just do not want to stick on one frequency, because we want to hijack existing channels and all that kind of stuff. Okay, so that's how we do it. And then we add a big antenna, but actually we use a small cable now because we don't want to piss off other broadcasters. That would be very bad. Of course, we didn't try it, right, with a big antenna. We didn't, like hijack soccer matches and stuff in Italy. We totally didn't do that. So this is the injection circuitry, RDS encoder and the FM transmitter, okay? So transmitted FM, so can be tuned to arbitrary frequencies. Important to have a stable one. We can cover long distances very easily. So if you push 1 watt of energy on that antenna, you can get 2 miles very, very easily, okay? Otherwise, you can just put a cable. So you see that LED going on? That's working an antenna right now. And then your range is like 1 or 2 meters. It's very, very close. So it depends on what you want to do. You either want to hide yourself in a tunnel and waiting for cars passing through, and you know they're not going to see the real signal because they're in a tunnel. But you're inside with an antenna, right? So they're going to pick it up. Or if you want to target only one car, you just build a very small device. You can stay in that one box, and then you hide it in the trunk. So they drive, they got this thing in the trunk, they're never going to be found out, and you're not going to affect anyone else. So, local laws is not going to find about it, okay? So that's cool. That's evil. And so that's our antenna, the Deserializer. He was staying out all the time. So resistance is future. No kids for you, no more. And I had to stay inside the car to check that everything was working properly. Well protected by my Faraday cage. Anyway. So, video clip time. Let's show to you what happens when we obscure a radio station, okay? So we tested this on Saturday and Sundays at the times where soccer matches are being, played. And we're in Italy, remember? So that's like major. We tune to our channel. As long as we get close, we can hear this static noise. So that's our channel, this one. That's 102.5. That's one of the major broadcasters in Italy. And you can hear nothing. We move away from it, and then you can hear real radio going on. Okay? So that's what happened. So we can obscure radio station. That's cool. So what we want to do is we want to find a way for hijacking the channel and sending our messages. So we have two ways for doing that. One way is why we hijack an existing channel. So we obscure your soccer match because we know that on that channel they're sending RDS-TMC messages. And we send 8 A groups, so the message itself. Because your satellite navigation system already seen all of those free A groups. It knows already that it wants to tune on that channel. So what happens? You got your navigation system, it says 10 seconds on every frequency. It gets the free A group. Okay, that's a good channel for me. I'm going to cache that information. I'm going to get back to you for getting messages. And so on and so on and so on. So on a navigation system, you usually get 2 tuners. One that looks in cycles, looking for free A groups, and then the other one that goes on the groups on the channels that were good, getting 8A groups information. So what we do here, we forget about advertising our channel. We just, hijack an existing one. We completely obscure your soccer match, and then we send whatever we want to send. Okay? You need to be careful with the timing, but it's very efficient and works. Also, there's one very important thing to keep in mind. The tuner of your radio in the car is different from the tuner of the sat-nav system. Okay? So this doesn't necessarily mean that the channel you're listening to is the same one that the satellite navigation is, detecting TMC messages on. Okay, so you need to be very unlucky if the driver is listening to the same channel. Okay, but if that's a concern and you really want to be stealthy, you can take a non-used frequency, whatever. You know that in that region it's not going to be used, and you broadcast free A groups plus 8A groups. So you fake the whole thing, and then your satellite navigation system is going to lock up on there, and the nice icon will go from red to green, and that means you're in business. Okay? So, of course, what happens is that on that specific channel, you won't hear anything. Okay? But there's one thing you can do for being stealthy. So most radio stations, they broadcast on the main frequency, and then you got a secondary frequency. Okay? You do not have the same frequency all over Italy. You move around and then you change the frequency, okay? And RDS radio systems are able to pick up the frequency automatically. You don't need to do anything. That's because there are some packets which send you the alternate frequencies. So what you can do, you can add an additional receiver in this circuit, and then you can tune on the secondary frequency for the channel you're hijacking. So that way you can remix your original audio in. So you can remix your soccer match again so that you won't be pissed off and you will never notice that I'm hijacking your channel. The only difference will be that the power will be a little, it will be a bit less powerful than that. So it's very easy to do, so you can be almost completely stealthy, okay? So let's demo what we're going to do here, okay? It's up to you.
Console?
Applause! It's talking!
Give me a console, Andrea.
There.
Not Black Hat.
Oh, sorry. You should talk or they get asleep.
Andrea,
Yes.
we have network problem.
Oh, we got network problems. So we're not supposed to have network problems. We're hackers. Just a sec. This goes here. This goes here. Maybe that's your problem.
Questo, scusa? No, c'è questo attaccato.
This one goes there. Which goes here. That's so lame, They're going to remember this issue.
Io lo vedo.
Is that right, IP address?
Yeah. Yeah, it's correct.
Don't let me down, please.
Sarà lo switch che non funziona. Attacca direttamente. Attacca direttamente il cavo. Attacca direttamente
Non
il
ci
cavo.
arriva?
Sul set.
Well, okay, let's skip this. We maybe show you at the QA session. Okay, we got it. Stealthy.
It's your fucking switch. Okay.
So, So what we're going to show you, so we got everything on the board. So what we're doing, we're injecting and sniffing at the same time, okay? So we're using one PC for everything. So we got the tuner there, okay? And we got an antenna there, okay? So that sniffs. And then, okay. And then we got a don't do that. And then we got our FM.
Okay.
If you fucking do that again, you'll be sorry. So then we got the injection system. So that LED over there, which is turned on, is our injection system. So our PC is sending and receiving the channel at the same time. So there we got the source code. So there we set our packet. So right now, what kind of packet is that?
It's a queue in the Milano-Genova that is a famous road.
Yeah, so very realistic.
Road. Yeah.
Yeah. So what we do now...
Also the PS name is realistic.
Is DEFCON?
Yeah.
Oh, that's very realistic. So right now, if you have a FM radio and you tune on the frequency we're using, you should see DEFCON as the name of the radio station, which is cool. So program the whole thing.
Yeah, so the PS name is DEFCON, the PI code is 5218, and this is the payload of the packet that we want to inject. So Q in the Milano-Genova.
One more beep.
Let me do that. Okay, so now we are writing on the EPROM of our RDS encoder. Okay.
So that's over parallel port, right?
Yeah, it's quite so. So, okay.
What was that?
Oh, don't worry. Oh, this fucking keyboard. Okay.
That's a ThinkPad. That's the best keyboard ever. So shut the fuck up.
Okay, so this is the stream, the RDS stream that we get directly on the serial port of the PC.
That's like the Matrix. Isn't that cool?
So we can grab it.
You can actually see the structure over there. You can see there's a line going there. There's a recurring set of numbers going from top left to bottom right. Okay, that's probably either our location code or the PI code. So you can see there's something going on over there.
So now we can use our decoder SRDSD minus T because we want to see only the TMC packets. Minus D, we can specify a database location table.
So that's a very good quality signal. There's no bad data over there. In real life, if you're tuned correctly, you see almost like that. You might get like 1 or 2 bad bits every packet or so. But if you convert those to 0 and 1, it's going to be just fine. Okay. If you have a very, very crappy signal, then it's like half of them is bad quality. Okay. Sorry. Yeah, you can talk now.
Okay, thank you. Now the PI code, 28, I don't remember, and the stream file. Okay, wrong PI now. Okay, so this is the output of our.
So that's our packet. Does it show a queue?
Okay, so you can check that it's the same that we have prepared before. So the event code is queue traffic.
If you're pointing your finger on my laptop screen, that's not going to be very helpful for them, isn't it?
Okay.
We're not there yet, technology-wise.
Okay, so
maybe Apple is working on that, but I don't know. Sorry.
So the event code is our fucking queue traffic. The road code is Milano-Genova, so you have also the link to Google Map.
Okay. So it works. Cool.
Thanks, my fix.
You don't deserve this spot. So, the fun part begins. What we can do, we can create queues. Bad weather, rain, smog, fog, fresh snow, thunderstorms. Silver Surfer, everything. We can create full car parks. Oh, Dad, I so want to go to the amusement park. You cannot. The car park is full. I'm sorry. So that could be useful if you have kids, right? Yeah, look, it's full. So overcrowded service areas. Oh my God, that's kind of useless. I mean, if you gotta go, right? So, but anyway, it's there. Accidents, roadworks, and so on. It's not very exciting, but it's still nice. It gets much better now. Okay. So that's an example, code 108, queuing traffic. Okay. So you can see the icon over there. You can see that the road, instead of being red, is like bluish because that's the affected road. Okay. So there's a queue. And if we put it a version bit to 1, the silent navigation system is going to say, oh, there's a queue, get lost. Closing road. We can close arbitrary roads, bridges, tunnels with a number of events. There are more than one events for that. Okay. So what happens here? The satnav will pop up the event telling you the road is closed, which is very believable. I tend not to trust queues and accident messages because they might be old. Okay. So I just go on. If I see a closed road, I might really believe that. My dad surely will believe that. So, but there's one interesting thing. If the closed road is encountered during recalculation, which happens all the times because you get in a tunnel, you lose the GPS signal, the route gets recalculated. You miss a turn, which happens all the time, especially in Italy, and the route gets recalculated. So if the road is closed, the navigation system is going to silently detour you. It's not going to tell you about it. So if you're driving my place and you don't know the road, I can close all the roads around you. You're going to miss a turn at some point, and I can just detour you wherever I want. And then the hitman with a gun can, shoot you because, oh. So that's bad. So this is also known as keep your parents from reaching home, or keep your girlfriend from reaching home, or keep your boyfriend from reaching home. Whatever, just, pick one. So that's closed roads. So we close the Trieste Venezia, which is, big road, okay? So you can see there, so that's the event list, and there on the road you can see a closed sign, and it's closed, and there's the pop-up. So we can detour or we can, return. This is the silent detour thing. So the first image, that's my normal route to home, okay? You can see the blue line. Then I inject the message, and we can see that it's closed, and we can see that actually the route, it's different. Maybe you cannot see that very well, but trust me that it's different, okay? So that's kind of bad. Security messages. The event table supports a number of security-related messages. So this is where it gets fun. Without anyone ever used them so far. And when the States, you got TSA, Homeland Security. So imagine this, like you got president or something with an escort, okay? And these guys are trained to stop everything on the first sign of suspicion, okay? So what do you think it will happen if they see terrorist incident in the cellular navigation system? They will go, oh fuck. So that's bad. You can put a terrorist incident everywhere. So I don't know why they planned that in the standard, but it's there. Air raid, danger. So I imagine, your FM broadcasting station, oh, we got an air raid on the highway, so maybe we should send a warning to our cars. And they're so polite that in the standard, you can send air raid stopped. You can, go there. So you can advertise the air raid, and you can say, okay, look, it's done, so feel free, do your own thing. Be merry on the way. So that's our air raid on our coast road, that's major. So when I started working in the IT business, so I was, trying to make my dad understand what was going on. So, hey, Dad, I can hijack system calls from the latest Linux kernel. And my dad went, get a life. So when I show him this picture, it was, oh, wow, your job is cool. It was, oh, finally, 10 years after. So we're so sticking to these things. They're much, much better. So forget code for now. Car are cools. Air crash. And if you think that's not believable enough, so we put an aircraft near an airport over there. So you got your airport and you got your air crash. I mean, I would believe that even if I know that I can inject messages. So that's kind of major. Bomb alert. TSA would totally love this. You can put a bomb alert in an airport. So, That's bad. So, and of course you can pop up these messages, okay? So this will security alert, stationary traffic, so code 1571. So let me show you. So this video clip will be World War III on a highway. So I'm plotting my route. I want to go there. Toll road, yes, I can pay. I wait 5 seconds. Nope, security alert, stationary traffic. There's the hacker over there. So, what shall I do? Oh, let me return. I don't trust this thing. So, let's see the event list and actually see what's going on. Bomb alert, security alert, air raid, close, World War III on a highway. Whew. Funny messages. Bullfight! So you can put a bullfight on a highway. So I dream about a story about this one. So I imagine the European community, having this big meeting. So, and they're going for the event list, and someone like the chairman is saying, bullfight, why do we have this? And the Spanish people go, we got those, we asked for those. So that's my story. I think bullfight, they asked for that. You can get delays due to parade. So you can put a parade on a highway. That's cool. And then you can also put people on the road and then accident. Yeah, that would be fine. So there's one other cool thing. You can get a boxing match. So you can put a boxing match on a highway. But you know that when you get an accident in Italy, a boxing match after that is not so unrealistic. So that kind of makes sense. And no, you cannot have a pony. I was so sad because of that. Anyway. Implementation issues. So there are a number of implementation issues. So we thought when we were first doing this thing, okay, so we got to be careful. We got to match the PI with the frequency we're using. So it turned out if you're using PI code 6666, it doesn't occur. The navigation system is going to pick up your messages. So it's even much more easy to spoof messages. There are some codes which are allowed by the standard but are not supported, like total cancellation. You cannot cancel all the messages, but what you can do, you can cancel all the single ones, because you can only have one event per location. So you got your broadcast station sending a queue, okay, let me cancel that. Sending an accident, okay, let me cancel that. So I can do another service and remove all the messages from the navigation system, okay, so they will go there even if there's a queue or something like that. There's a broadcast message which is not honored at all, so what we want to do is like pop up bomb alerts on all navigation systems even if there was no route at all being plotted, but we cannot do that, at least with our navigation system. Maybe with some others you can do that. Diversion bit is totally ignored by most implementation, so you put it to 0, you send an accident, the car is going to pop up the event anyway. You put 1 to like snow, the car is going to ignore the event. So it's there, but it's not being used at all, okay? So we expect other navigation systems to have similar or even more interesting issues. We only tried 2 because we don't want to, waste money on buying like 10 or 20 different navigation systems. So, but that's it. Encryption. So there is encryption. It's a very lightweight encryption, and it was used only for commercial services. So at some point, vendors got, okay, we would like to sell this service. But how can you sell this service? You're broadcasting, your station picks it up, you can see it. So what they find out, we can encrypt the location code. So what they do, they use a different encoding, because it's not encryption at all, for the location code. So a normal satellite navigation system is not going to have that location code, so it's not going to show you the message. If you pay subscription and you get the proper set of location codes, then you can see the message, okay? So the problem is that only the location code is encrypted, so you can actually see what's going on. And even if I don't know what the location code is, I can just modify everything else and then use the location code you sent, and then I'm in business. But the encryption are bitwise operations. So bitwise operation is not encryption. You can sniff there, you can get like 10 or 20 packets, you can correlate that with real messages because you have a navigation system that works, and then you can find the key and do whatever you want if you really want to read and hijack those messages. But we don't care, because every navigation system is supposed to be able to receive commercial services if they have subscription, as well as free messages. So I can just send my own messages and it's going to pick them up. is not relevant at all. So don't think about RDS-TMC encryption as a security measure. It is not. It's just for discrimination. So what we've seen can be trivially injected. You can get a check because of that. So that's, end of story. Drivers don't tend to have any security awareness. So if you use a computer, you can get viruses and stuff nowadays. If you drive a car, would you expect that someone can do something like this? I don't think so. Well, now you can. So we don't think it's the end of the world. It's not like we attack this protocol at all. I mean, it's very old. It was designed to reuse existing infrastructure, which makes perfect sense. But since they want to have your car doing more and more things with your navigation system, and it's vital that in the future we don't commit the same mistakes we did with our services and unencrypted protocols in the past for computers. So just please use authentication, use encryption, whatever you want, give me integrity, but just don't let this thing clear text, because maybe 10 years from now we'll be very sorry if we made that kind of mistake. Also, cars have a long lifespan. I cannot upgrade my car like I can do that with the software on my computer. And sure, I'm not going to change my car because I have a satellite navigation system which is vulnerable to these kind of things. So they have a very long lifespan. And that's why we use RDS-TMC now, which is way old. So we should be careful with that. And we hope the future protocols will have, some security. So we got an official response from the people doing this protocol. It was very fun. Let me read it for you. The title of the article was Hacking TMC Unsuccessfully. Hello? We did it. The first and overriding statement that should be made is that transmission of this type are directly analogous to pirate radio broadcasts, and certainly will, in the case of Europe and the US, contravene each country's respective broadcasting legislation and laws. Oh, thank you that you're telling me it's illegal. I'm sure that will stop any attacker. So killing people is illegal. Oh, we're safe. That's fine. There is a chance that a false message could be decoded, but a degree of knowledge would have to be gained on the parameters of the message being coded. It's clear text, I can make it out, I can do whatever I want. The random use of any location code would result in a randomly located event. Also, random choices of event codes may not cause the terminal to react. Did you see me using random codes? I don't think so. We know exactly what we can detect, and we know exactly what we can send. So this is plain FUD. And this was after our presentation was available. Then there's a whole bunch of crap about this frequency will not be either in the main AF list or the secondary AF list broadcast in any of the tuning variants of the TMC data. That's crap. It doesn't make sense at all. The radio station can do that. I can do that. There's no magic involved. This is not magic. And the last one is the most hilarious one. Service providers and broadcasters, I am sure, have many protection mechanisms and processes in place to prevent any legitimate access to their services within their infrastructure. So Faith manages. So these guys are doing the protocol, and they're sure people, they have protection. So that's crap. So you can read the full response there, and you can read our reply to their response there. So if you wanna, I didn't extrapolate sentences out of context. Trust me on that. Never been so hard to convince people that clear text protocols are bad. Never. So the future, TMC is also supported over digital and satellite radio. It's harder to inject because you need to do more hardware and stuff, but it's the same thing. There's no encryption, there's no authentication going on. TPEG, this Transport Protocol Experts Group, is the new standard designed for placing TMC. They support encryption, but it's optional, and it's like encryption. So you got these bits, these are for encryption. They don't tell you what kind of cipher you should use. They don't tell you anything about that. So I can use a null codec, and that would be nice. So they really need to do stricter definitions. And they replied to us, and it was very hard to convince them about the fact that it's a security issue, but they said that they will consider in the future having stricter requirements. So there's a new cool thing going on, which is GST, Global System for Telematics. It's an impressive project. BMW is backing it up and all people. So what I want to do, you put a credit card in your car, and then you can download services and system and traffic information. So smart. It's going to use PKI and SSL, so in theory, it should be hard to do anything about it, right? And it's very sad to realize that the encryption comes only when there's a commercial side on it. As soon as you put a credit card, then they want encryption, okay? So it's not that good. But anyway, so this thing will not happen, anytime soon, but, we're still looking forward to play with that. Trust me on that. Similar system. So in US, you got also Microsoft DirectMan, which is like RDS on steroids. So they use a subcarrier. They have 15 times the bandwidth of RDS system, and it works pretty well, and they have encryption going on there. And I read some papers, and it looks done properly. Of course, we didn't play with that, but it's promising. But of course, we cannot get that in Europe at all, or everywhere else, because they cannot get that frequency licensed at all. That's a carrier licensed at all. So this is the end of our talk. We hope you enjoy that. And we can either get questions here, or maybe we'll move to the QA room so that we can answer to whatever questions you might have. So thank you very much. I hope it was fun for you. And as you can see, he has a future as a porn actor.